Okay, so we're going to take a look now at, we're going to bring three concepts together, right, in order to do the immediate inferences on the second part of section 4.3 in chapter 4, right? So the three things that we need to bring together. We need to recall the definition of validity. Number one. Number two, right? We need to recall A, E, I, O propositions. We need to know what those letters are, right? So, and then we need to take these two things and then we're going to apply them to something called immediate inferences. Immediate inferences are almost categorical syllogisms. What they are is they're two lines. They have a premise and a conclusion. Now, let's talk about validity. Remember, validity only refers to deductive arguments. And what we're going to do is we're going to explain deductive arguments, right? Now, the immediate inferences uses the third thing, which ultimately we're going to bring together is the notion of the modern square of opposition, which I'm going to go over shortly, right? But I'm going to draw it here just for your own reference, right? Now, these diagonal lines are we're going to call contradictories. And so the logical relationship between these propositions along the x's in the middle between E and I or A and O, they are contradiction. And immediate inferences uses this notion of contradiction. And the immediate inferences and the modern square of opposition. So first, I'll go back and explain validity, right? So these three things. And because this is a video, I can erase the board and you can always go back to what I was mentioning previously by moving the tab, right? So first, let's go over validity. Validity is the property of a deductive argument such that if my premises are true, it's impossible for my conclusion to be false, right? So remember, validity is a property of deductive argumentative form such that if my premises, right, premise or premises are true, it's impossible the conclusion be false. So if you have like premise one, whatever it is, and that's true, and then you have the conclusion, whatever it is, and that's false, and premise one and this conclusion are in deductive argument form, if you get true false, then you get an invalid argument, right? And consequently, if you got true, it would be unconditionally valid. So we're testing for unconditional invalidity of these two-line arguments. We're also testing for unconditional validity, right? Because when you've got premise one and conclusion. Now, in order to test this out, what we're going to need is we're going to need to understand the modern square of opposition, right? So I'm going to go back. Well, so, I mean, I'll go in the book and I'll show you the one in the book, but, you know, it's a little bit easier just for me to kind of like, right? Now, in order to sort of explain the modern square of opposition, there is another concept called contradiction. Now, formal contradiction in logic, right? Imagine if someone were to say, they walk into a classroom, no matter what classroom you walk into, right? Or classroom you log into, because this is an online class, right? Or possibly an online class. I mean, I could use the video for like both my in-person and my, you know, anyway, right? So if someone walked into a classroom and said, we will have a pop quiz today, and we will not have a pop quiz today. Right? Now, this is technically what a contradiction is. A contradiction is two sentences linked with an and. Sometimes in logic, we call this a conjunction, right? And in grammar, we call it the coordinating conjunction. This is the and. But a contradiction is that these two statements cannot both be true or false at the same time. So if this one is true, then this one must be false. So really, it's being utterly inconsistent with an and. It's really what it is. It's you know, you could think of it this way. If we were to write this out, we could say, I'll just symbolize this by like W. It doesn't really matter, right? I'll symbolize this whole sentence by W. We will have a pop quiz today. And not W. That's technically right. So this is a little bit more like what the formal logic is. But a contradiction is a sentence and its negation maintained with an and at the same time. But neither of these things can be true. It's either you're going to have a pop quiz that day or you're not going to have a pop quiz that day, right? So like, imagine I walk, since my wife works here currently, I don't know if that's going to be true forever, but she works here as the admin. And I walk into Ashley's office and I say, I love you and I don't love you. Any spouse is going to be like really confused with that, right? And they're going to be like, well, which one is it? Now, when someone says, which one is it? What they're doing is they're demanding consistency for the purposes of logical thinking, right? So it's either true or false. But if you maintain a positive statement and the negation of that positive statement with an and, that's a contradiction. And you can't maintain both of these as true because by logical definition, one of these must be false for the other one to be true, and vice versa, right? Now, consequently, most days when I go into class, I really don't have the idea of pop quiz in mind. Unless, of course, the class isn't really like doing a lot of the readings and in class, it's just like, oh, I need to hold them accountable to some standard because they just refuse to read the philosophical text in my philosophy classroom, right? And that's usually the reason why professors give a quiz. It's like class as a community are not doing the things that they need to do. So that's a contradiction. Now I've explained what a contradiction is. And you're like, okay, Dr. Hackett, well, that's great. That's what contradictions are. Now remember when I drew the table previously, and I said, look at this. This is the modern square of opposition, right? So in order for, now it might seem to be kind of strange, but that same relationship of contradiction is along the axes of the x in the middle of the modern square of opposition, right? So I'm not going to write the word contradiction anymore. I'm just going to put A, which symbolizes all SRP. E will symbolize no SRP. I will symbolize some SRP. And O symbolizes some S bar not P, right? And because these are contradictions, I can use the relationships between A and O, O and A, and I and E to determine truth values of statements. So when we look at the immediate inferences, it'll become a little bit more clear. But think about this, right? And I'm going to like do the pause to consider thing with you. So if A and O are in contradiction with each other, and A is true, O must be what? Pause to consider. False. If O is true, A must be what? True. If E is true, I is what? False. And if I is true, E is what? False, right? So if if we know the truth value of one of these, I immediately know something about O. Now the dotted lines, the book will put logically undetermined. All right, you could say logically undetermined or are invalid. That's fine. Right, I just usually say the logically undetermined because if I know I is true, I know E is false. But if I is true, I know nothing about O or A. Right? Because there's no formal relationship apart in the modern square of opposition other than contradiction, and contradiction is the x's. So remember, we're bringing in validity, and we're going to use this chart. And if we have one line, if we say we have the premise 1 and we find out that it's true, and then we have the conclusion and we find out that it's true, that's going to be valid. And if we have like premise 1 and whatever it is, right, and then we have true, and then we have the conclusion, and we have whatever it is, and then we get false. If we get true, false, we violate the definition of validity. So a couple of chapters ago, you were wondering, why are we learning the negative definition of validity? Why is it that such that the premises are true, it's impossible for the conclusion to be false? Because we use that definition to test arguments about whether or not they have a valid argument form, right? So a lot of this course is, we have this definition of validity, and then here's some arguments. Let's discover if they're valid patterns or not. That's part of the tracking, the skill tracking of the homeworks, right? And so immediate inferences are kind of our sort of first proto process to get into this and to kind of see. And of course, we're going to use this modern square of opposition. This modern square of opposition was invented by Bull, and we're adopting the Boolean interpretation of universal propositions in order to use this table, right? A lot of the other logical relationships assume the Aristotelian standpoint. And that's why it's necessary to explain both, even though I'm only going to use one, because I'm not going to go into section 4.5. Okay, so let's take a look over here. Let's actually go to the book. And there's going to be some more visual things that we can see, right? Concise introduction to logic. Where are we over here? This is 4.3. So this is the modern square of opposition, right? This is, of course, this is a prettier picture than what I drew on the board just a moment ago, right? Let me put that in the middle, right? And these are contradictory relationships, right? But if I is true, E is false. If E is true, I is false, and vice versa. So the opposite truth value. So let's take a look at testing something like this. So here we have some trade spies are not masters at bribery. Right, and that's going to be in the premise 1 position, and then the conclusion here is going to be it's false that. It's false that all trade spies are masters at bribery. Right. Now, there are a couple ways to kind of go with this. Right, but we'll go back to the book in just a second. But let me go here. So here is the sample from the 4.3. Right, some trade spies are not masters at bribery. It's false that all trade spies are masters at bribery. So what we have to do is we have to use the definition of validity, the knowledge of the contradictory relationships between these, and also recognize what propositions are here. So, and don't worry, we're going to do a few of these problems together because this is probably a little bit more of the challenge given how much information is in 4.3. I don't like how this section is organized. That's why I'm also doing 2 videos, right? So first off, we can only test for unconditional validity if we have a relationship between A and O or E and I. So we need to take a look. The first thing you need to do with the immediate inference problems is see, do we cross the dotted line? If we cross the dotted line, it's going to be logically undetermined, immediately invalid. So some trade spies are not masters at bribery. Is this an A, E, I, or O proposition? Pause to consider. That's right, this is an O proposition. Now, O is only in relationship to A, so the bottom one has to be an all SRP for me to even proceed further in using this diagram. So we have, it's false that all trade spies are masters at bribery. Now we have this, it's false that. This is going to tell me the value of what A proposition. So this is an A proposition. So the question is, do A and O stand in relationship of contradiction with each other? Pause to consider. Yes, they do. Given that there's a contradictory relationship, I can actually test for validity here. So in order to test for validity, the first thing you do is you assume the premise true, right? So we assume that this O proposition is going to be true, right? And then we know if O is true, A is what? Pause to consider. Did you say false? Well, this proposition tells us it's false that, and then it gives the A. So this, it's false that is kind of convention to tell us what the truth of this proposition is. And it's a convention. And by saying it's false that, and then if you want, you could think of it's false that, you can put it in like quotation marks, that makes you help you think of it as like as a unit, right? But it's telling us it's false, which is ultimately for the conclusion, it's telling us something true. It's telling us the truth value of A is false, and that's technically true. And because we get true, true, we immediately know it's valid. That was a lot. You're like, can we do another one? Absolutely, right? So let's say, well, actually what we could do here is, right, what if I said to you, what's that? So we got the sum, right, and then so you. I'm just sort of changing it to be something else so that we could do the same thing. All right, so I have changed it a little bit. I've changed it a little bit, right? So here's premise one. Our new statement is no trade spies are masters at bribery, right? And then we have conclusion. It's false that some trade spies are masters at bribery. So I have changed it slightly. Now remember, in order to determine, in order to use this chart, the modern square of opposition to its fullest extent, we need to be in contradictory relationship between one and the other, right? So we need to ask ourselves, is the premise A, E, I, or O? Pause to consider. Yes, it's E. All right. And then the conclusion here is some trade spies are masters at bribery. Is that A, E, I, or O? Correct. That's an I proposition. Now, are E and I along the arrows here? Yes, they are. So they stand in contradictory relationship. So if I know the truth value of one, I will know the truth value of the other, right? So in order to determine unconditional validity or invalidity with the contradictory relationships in mind, right, we need to say, okay, well, they're in contradictory relationship. the next thing I do is I assume the premise true. If the premise is true, we want to test for validity. If we get a false conclusion, it's what? Invalid. If we get true, we know that it's what? Valid, right? So I assume this whole proposition true, right? And so if E is true, right? If E is true, I is what? False. And this conclusion says it's false that some trade spies are masters of bribery. So it's telling me something true about this thing, which is false, right? So, and that part of it, right? So it's false that is describing this proposition inside here. And this whole sentence is saying something correct about this I proposition that's false. And in that case, it's saying something true. And so this version is unconditionally valid, right? Now let's take a look at the sample problem and take a look at how the book conveys what I just said to you. It's going to say the same thing, but we're going to say it in two different ways. And if you're still confused, that might help unite these things and put them together. So let me share the screen. All right, so let's go here. Arguments of this sort are called immediate inferences because they have only one premise. Instead of reasoning from one premise to the next and then to the conclusion, we proceed immediately from the single premise to a conclusion. To test this argument for validity, we begin by assuming the premise, which is an O proposition, is true, and we enter this truth value in the square of opposition like we did. We then use the square to compute the truth value of the corresponding A proposition. By the contradictory relationship, the A proposition is false. Since the conclusion claims that the A proposition is false, the conclusion is true, and therefore the argument is valid, right? So that was the first one we did, not the modified one. Note that the conclusion of this argument has the form, it's false that all SRP. Technically, statements of this type are not standard form, but because, among other things, they do not begin with a quantifier. To remedy this, to remedy this difficulty, we adopt the convention that statements having this form are equivalent to all SRP is false. Analogous remarks apply to the negations of EIO propositions. So let's actually write this one on the board. All right, I'm going to write this one down. Let me erase this. And we're going to all right, so we have it's false that, right, all meteor showers are common spectacles. I actually like that. I mean, this is also the summer of the James Webb Telescope, so I don't know. I find the pictures of the universe completely fascinating. Right. And then therefore, I'm going to do three little dots for the word therefore. No meteor are common spectacles. Now, this is actually an interesting one, just in the sense that, all right, let me go back. Right, obviously you might have read the video there a little bit, or maybe you weren't, maybe you're just listening to me. All right. This is the other kind of variety of problem that we're going to get, right? So we're going to get, it's false that. Now, the first thing you need to do is ask yourself, is this an A, E, I, or O proposition? Pause to consider. All meteor showers are common spectacles. That's what? Correct. That's an A proposition. And then we have no meteors are common spectacles. Is that A, E, I, or O proposition? Pause to consider. That's an E. Given the fact that I have A and E, take a look at this chart. Do A and E stand in any contradictory relationship where I can use the chart further to test for unconditional validity or invalidity? No, because they're not. I can only do that with an A with an O or an E with an I. So I'm crossing the dotted line. Any crossing the dotted line will immediately become logically undetermined. And if it's logically undetermined, you could say it's invalid. But at that particular point, right, I can't really test for validity any further. And in the homework, there's going to be several examples of these problems right here, right? So now let's actually go to like 1 or 2 sample problems in the homework. We can actually take a look at the book here, right? Now we begin by assuming the premise is true. Since the premise claims the A proposition is false, we enter false into the square of opposition. We then use the square to compute the value of the corresponding E proposition. Since there is no relation that links the A and E, the E proposition has an undetermined truth value. Thus, the conclusion of the argument has an undetermined truth value and the argument is invalid, right? So logically undetermined immediately means that the argument's invalid. Of course, you could say the same thing with Venn diagrams. We're not paying attention to that, right? And there's a lot of that. So now we don't, in 4.3, we don't actually draw Venn diagrams in Roman numeral 1. We do Roman numeral 1, we do Roman numeral 2 instead. So use the modern square of opposition to determine the following immediate inferences are valid or invalid, right? So number 1. No sculptures by Rodin are boring creations. Well, maybe it's easier. You could pause here to just kind of like take a look at the first 3, right? How many are there? There are 15 of these. So if I do 3 of them with you in this video, right, you'll see. But immediately, like once you get to do this chart and you do a lot of these problems, you can kind of see here, right? So ask yourself right now, no sculptures by Rodin are boring creations. Is that A, E, I, or O proposition? Pause to consider. E, that's correct. Therefore, all sculptures by Rodin are boring creations. All sculptures by Rodin are boring creations. Is that A, E, I, or O? Well, that's right. That's an A. So again, just like the sample problem up above, right? Just like the sample problem above, that's an A and an E. Immediately, we're crossing the dotted line. So you can immediately see that you don't even need to go through all the steps of the problems that do stand in conflict relationship, because that's logically undetermined and that's immediately going to be invalid because there's no formal relationship between A propositions and E propositions that if I assume the premise true, I don't know what the truth value of E is going to be. I only know these contradictions along the internal X of the diagram, right? So now let's go to an actual one, right? So let me go back. Share my screen, right? Let's see. No. Okay, so let's do number 2. And you know, what might make this easier, right? So take a look at number 2. It's false that some lunar craters are volcanic formation. I'm going to keep this up as I write. I'll switch the board in a second. So hopefully you're going to get the hang of these. All right. But they really do kind of introduce to us the first type of argumentation where we're using the definition of validity in a formal way to test for validity or invalidity, right? Categorical syllogisms are 2 premises and a conclusion, and we've seen examples of that, right? So, but here is kind of a trick, and I'll show you the trick when I come back here. So, premise 1, it's false that And then some lunar craters or volcanic formations. What is that? I'm just going to say it's false that I, right? That's an I proposition. And then P1, conclusion, right? No lunar craters are volcanic formations. Rather than write no lunar craters or volcanic formations, I'm just going to put conclusion E, because it's an E proposition, right? So let me go back here. So for problem number 2, I've written it's false that I, and then conclusion E. I don't know if this is easier for you to think this way. I mean, you might want to write them out, right? But I mean, it's important to see the relationships here. So it's false that I. So in order to test for validity, I'm just going to assume this to be telling me something true about what the sentence is about. And I is this, it's false that tells me what to plug in for the I proposition. Now the E and the I stand along the X, right? And that's why I sought out to do the problem number 2 with you, right? So it's false that I, that's telling me some information. It's telling me what to plug in. So I'm going to plug in the false for I. If I is false, E is automatically what? True. So E unmodified for itself, right? And there's no, it's false that here. It's just no volcanic formations, R craters, yada, 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 whatever it was, right? And so I get true, true. If I got true, true, I immediately see that it is valid, right? So what I think might be what's easiest for me, or maybe it's just easy for me because, you know, I've been teaching this for so long, but plug in it's false that I, or it's false that A, and maybe just write out, because if you think of these propositions, it doesn't really matter what the content of them will be, right? Because what you're trying to do is you're trying to see which forms they resemble, and then you're going to use this chart and plug them in, right? So let's do one more together, and that will leave you 12 to practice, right? So we'll just go in order number 3, right? But hopefully I think that you're getting this a little bit, right? So the order of solving an immediate inference, assume the premise true and look to see if it's a contradictory relationship or not. If you cross a dotted line, it's immediately invalid. But if there is something about A and O's together, or E and I's, right, then you can actually use to go further. Now, if you get true, true, it's going to be valid. And obviously, we're using this chart to determine the relationship between these two statements, right? That ultimately should be clear right now. All right, so let's go back to number 3, right? So all trial lawyers are people with stressful jobs. Okay. The A, E, I, or O? Pause to consider. Yes, that's an A proposition. So I have A unmodified. So premise 1, A. My conclusion is some trial lawyers are people with stressful jobs. So is that A, E, I, or O? Correct. That's I. All right. I'll stop sharing. Now, this is number 2. This is number 3. I have an A proposition and an I proposition. Do the A and the I stand in contradictory relationship with each other? No, absolutely not. So, again, we're crossing the dotted line. That's logically undetermined. Now, let's ask ourselves another question, right? Let's ask ourselves if we had an A and an O, right? And let's just say if you want content, and there's no it's false that's, right? So A, all dogs are mammals, right? And then we'll do O. Some dogs are not mammals, right? Let's just say that that was our problem. That's one I'm making up. That's not actually in the homework, right? Now I would assume this to be true. So I assume this to be true, right? And if A is true, O is what? False. And O is left unmodified, so that would be false. That technically is a contradiction in terms of the immediate inference, and thereby rendering it invalid. So this would be an example of where you would get true and false, and that would be invalid down here, right? This whole thing's invalid. So there you go. So that's another example, right? So if you just had these letters in an immediate inference on top of each other, that itself would be a contradiction, which would automatically make any reasoning invalid. Now, the conceptual reason why this is the case is that, you know, all dogs are mammals, some dogs are not mammals. Wait, there's no dog that's outside mammals. So obviously, if this is true, this would have to be false, right? If no reptiles are mammals, you can't have some reptiles are mammals, right? Because there couldn't be at least one that would be both because they never touch. So think of it that way, and just like you could take any true statement defined in terms of the content of an A proposition or an E proposition, you couldn't maintain these contradictions, right? They can't be held together. And so that's a good example to kind of illustrate both what contradictions are, and if we put those contradictions in the immediate inference relationship, like this homework is doing, immediately all the contradictions would be invalid. Because we want to be consistent. We want to say true things. You don't want a professor coming into the room and being like, we're going to have a pop quiz today, and we're not going to have a pop quiz today, because anything that person would be saying couldn't be trusted because their statements are not consistent. So consistency of statements, all true statements cohere together, right? Like if you have a book that's written and it has all true sentences in it, it's a good book, right? You want people to say things that are consistent. That's why also the definition of a hypocrite is one that, well, they say one thing and do another, like they're your friend, but then they talk about you behind your back in unfriendly ways, right? That's what we often call a performative contradiction. And hypocrites are inconsistent in both speech and deed. They say one thing and do another. And the other thing that they're dedicated to is actually the negation of what they're saying, right? So if someone says, oh, yeah, I'm your really good friend. I was just drunk that night. Maybe. And I was just saying really bad things about you. But like, you know, I wasn't in the right mind. You know, I was influenced by drugs in my system. OK, maybe. But if they continually do that, they're not your friend. So a friend is someone that says what they're about and what they say is consistent with their actions too, right? Because truth and consistency matter. If people say a bunch of different things and they're all contradicting each other, then they couldn't be maintained as true together, right? So some people think of knowledge as like statements that all must cohere together because they're consistent truthfully. And what makes a statement true is how well that statement coheres with a body of knowledge, right? So if we make an observation that we could never make before, and our theories don't go well with that, then our theory gets called into question because we're now making observations that make no sense with the model that we have on hand, right? So this is all just sort of tying together why it's important to avoid contradictions, right? Think about it like this too. If you were to say things that were both true and untrue, and you maintain them both as true in a formal academic paper, whether it's a sociology, English, or psychology paper, doesn't matter. The author, the prof is going to be like, you're contradicting yourself, right? And so when we write papers, we never want to contradict ourselves. We never want to maintain two theses in a paper one, like in this paper, I will argue that abortion is moral, and then later on the line you say abortion's immoral. Like the paper itself would be contradicting one thesis, right? So you always want to make sure that all the statements are in support of your thesis. And it's another way of saying that you want to maintain statements that are consistently true together. And that's an important logical virtue. And so I want to speak a little bit about that just as like the takeaway from the lesson here, right? Okay, so this is section 4.3, immediate inferences, looking at some homework sample problems from the book, and how we're using the modern square of opposition, the old definition of validity, and what we're learning about the names of these things and their abbreviations in 4.1 and 4.2, sort of bringing it all sort of together, right? Okay, I'm Dr. Hackett. Thank you for listening, and remember, thinking logically.